let's remind ourselves what is 7.1 and 7.2. So let's take a look at A. If you look at A, this is the first thing we need to do, or the first thing you need to recognize is because it's a division, we need to convert, we need to change the division to multiplication. That's the first thing we need to do whenever we deal with a rational expression. So A, let's take a look at this thing here. The first thing we need to do is we need to change division. So let me rewrite everything in terms of the first fraction or rational expression here. And again, we need to convert this become a multiplication. And then what do we need to do with the second parenthesis? The second parenthesis, once we change it to a multiplication, we need to take the reciprocal, or in the sense, we need to flip this thing around. So this is our problem, or this is what we need to do first. Whenever you see a division, we need to convert to multiplication. And now this is what I asked you guys to do. Just imagine that we have 1 problem, 2 problem, 3 problem, and 4 different factoring problem. Okay, so at this location, at 1, we treat this as one individual problem. So at 1, what can we do? Or this is basically, we need to ask ourselves, what can we factor out? And hopefully you all see that this thing here is an easy factor, because it's that 2 number multiplied to give me 30, but add together to give me 11. So because we know that 5 times 6 is 30, right? 5 times 6 is 30, and 5 plus 6 is 11. So we know the multiple is 5 and 6. And because we add them, both of them have to be the same sign. So everybody see that at 1, my factor become x minus 6, x minus 5, right? Again, this is what we have, is each of this thing here is a factor problem. So again, because the 30 is addition, we think in terms of addition, which in order for you to add, you need to have the same sign. So both of them would be negative, because negative 5 times negative 6 to give me a negative 30, a positive 30, and a negative 5 and a negative 6, when you add them together to give a negative 11. And at 2 is that 2 number multiply to give me 24, but subtract together to give me 2. So if you can see, or if you look at this thing here, 4 times 6 is 24, and 6 minus 4 is 2. And because we think in terms of subtraction, one of them have to be negative and one of them have to be positive. So in this case, everybody see that this is my factor. Negative 6 times 4 will give me negative 24. Negative 6 plus 4 will give negative 2. So this is what we need, ladies and gentlemen. Basically, we have 4 different factoring problems, okay? And at 3, what do we do? Well, at 3, is that 2 combination, is that 2 number multiply to give me 16, but add together to give me 8. And hopefully you guys see that 4 and 4. 4 times 4 is 16, 4 plus 4 is 8. So in this case, my combination will be x plus 4, x plus 4. And at 4, at our 4 location, hopefully you guys see, or many of you probably say, oh, this is an easy one, Mr. Tran. This is a perfect square, which is 5 times 5. And one of them have to be positive and one of them have to be negative. So again, whenever you have a division, the first thing we need to do is we need to convert the multiplication division to become multiplication. And once we do that, now all we need to do is factor each of the numerator and each of the denominator out. And once we have this thing here, the only thing we're doing is now, do you agree that we have x minus 6, x minus 6, they are the same on top as on the bottom? I can cancel out. X on top and x minus 5 on the bottom, they are the same. I can cancel them out. And x plus 4 on top and x plus 4 on the bottom is the same. I can cancel them out. But reminder, I only have one x 4 on the bottom, so I can only cancel out one x plus 4 on the top. So this thing is gone, this thing is gone, this thing is gone, this thing is gone. Do you agree that the leftover, or the only thing that I have left, is x plus 4 all over x plus 5? And ladies and gentlemen, this is our answer. And the reason I put in the parentheses is just to tell you that the x and the x do not cancel out. In order for you to cancel out, they have to be exactly the same. Okay, if they are not the same, x plus 4, x plus 5, they are not the same. So you cannot cancel that out. Okay, so looking at this thing here, question with how to divide, this item here, how to divide your rational expression. Any question here, ladies and gentlemen? The answer that we have for A is x plus 4, x plus 5. Okay, so again, all of this thing here, we simplify to be that. So if you don't have questions, let's take a look at B. Let me, x 42, 5x. So B, this is, let me rewrite my problem down here. My B problem is 7 over x squared minus x minus 42 plus 5 over x squared 5x 14 minus 5x minus 14. So, please reminder, this is what you need to ask yourself is, what is the operation that we have? So in this case, we know that the operation that we have is addition or subtraction. And in order for you to add or subtract, the first thing you need to look at, we have a common denominator, meaning is my denominator the same? So as you can see, in this case, my denominator is not the same. And this is why I asked you guys to do is, if you have something with the x squared, before we do anything for addition and subtraction, factor them out. And if you factor it out, this is what you have. Again, do you agree? Is there two numbers multiplied to give me 42, but subtract to give me, hopefully you guys see that 7 times 32 and 7 minus 6 will give me 1. So this is the factor, which is x minus 7, x plus 6. And on the other side, is there two numbers multiplied to give me 5? I see that we have x minus 7, x plus 2. So this is what we need to do, ladies and gentlemen. We need to ask ourselves, the denominator, is there anything factor out? Because clearly, if you look at this thing here, clearly the denominator is not, right? The denominator is not, so now we need to have the same common denominator in order for you to add or subtract anything. And in order to find the common denominator, we need to find the LCD. And to find the LCD, to make it a little bit easier to find the LCD, factor them out, okay? And let me do it this way here. I did not do this yesterday because I typed everything up. But for me, if I were to do this by hand, let me show you what I would do if I were to do it by hand. So basically, this is what I have, ladies and gentlemen. All I need to do is, or this is one thing that you can do is take a look at this item right here. And take a look at this item right here. Okay. So I would try to be as neat. So this is what I tell myself, ladies and gentlemen. What am I missing? What am I missing? What do I have over here? Over on that I do not have on this side. Let me change the color so that you guys see what I refer to. So everybody see I have a red circle and a blue circle, or the red item and the blue item here. So inside my red circle, what am I missing that I do not have in my blue circle? Everybody see that I already have the x minus 7, right? Do you agree that I'm missing the x plus 2? Okay, so over on this side, I'm missing an x plus 2 that I have on the other side. In my red circle or eclipse, I do not have the x plus 2 as in my blue eclipse, right? So if I don't have it, I insert them in. And if I insert on the denominator, then I need to insert on the numerator. Okay, let me rewrite what I have over here. On this side, let me ask you guys this question. What am I missing over item, in the blue item, what I'm missing that I do not have in the red circle? Do you agree that I have the blue, x plus x minus 7, right? I'm missing the x plus 6. In x plus 6, I need to insert, and if I insert the x plus 6 on the bottom, I need to insert the x plus 6 on the top. And that is your LCD. Ladies and gentlemen, if you remember yesterday, I told you that you take the red circle and you put it together with the blue circle. And if they happen to repeat it twice, in the circle, you need to do is use it one time, which is your LCD is x minus 7, x plus 6, x plus 2. And if you look at this thing here, even though the order, yes, I agree with you guys, the order are a little bit off, but do you agree that on the denominator, I have x minus 7, x plus 2, x plus 6? Doesn't matter what is x plus 6 or x minus 7, 6, x plus 2, they are the same. So I did it, ladies and gentlemen, I did it. After a small sequence, not my ultimate goal, but my mini goal, right? I did this in order for me to add or subtract, my denominator have to be the same. And I did that, I insert what is missing on both sides, I insert them in, and now the denominator is the same. And if the denominator is the same, this is all you need to do. Green is hard to see, so let me change back to black. This is all you need to do. Since that we have the denominator the same, all you need to do is keep the denominator. So your denominator is x minus 7. Let's put it in descending order, x plus 6, x plus 2. It doesn't have to be in descending order, but again, this is what you have to do is once the denominator is the same, what is my top? My top is plus 2 plus 5x plus 6. Okay, so again, let's go back to my original problem. My original problem is this up here. My original problem is this right here. And in my original problem, I do not have a common denominator. My denominator are not the same. I don't have a common denominator. So what do I need to do? I need to find a common denominator. And to find a common denominator, I need to factor them out to see what am I missing. And whatever I'm missing on one side, I need to insert them in. And if I insert in the denominator, I need to insert on the numerator. Vice versa, if I insert on the denominator on the other side, I need to insert on the numerator. And and cap the denominator. Okay, so now we're still not done because we have to simplify the numerator. And to simplify the numerator, we need to combine like term. But in order for us to combine like term, we need to distributive the 7 in here, and we need to distributive the 5 in here. So I have 7x plus 14 plus 5x x minus 7, x plus 6, x plus 2. And now what are my like term? My like term is I have 5x, 7 and 5, 12x. And I have a 14 added to 30, that will give me 44 over x minus 7, x plus 6, x plus 2. And again, this can be your answer. This can be your answer. If you say, well, 4, you can factor out 4, but still, you can factor out a 4, but still it does not, you cannot do anything in the sense that everybody see that plus 11, and on the bottom, you still have x minus 7, x plus 6, and x. Also, again, yes, you can factor, but most of the time, this can be the answer too. So, or the left side, either whichever one is fine. It should be fine. Remember, we cannot cancel them out if they are not exactly the same. Okay. So again, let me ask you, or let me see if you have a question here. All right. If you don't have a question, let's do another one. And this time, let's do subtraction. Let's say it's C. And again, I make this off the fly. So let's say C, and let's do 8 over, let's do this thing here, x minus 81 minus 2 over x squared minus, let's do 3x minus 27. Okay. So if you look at this problem, clearly we see that the denominator, again, we know that this is a subtraction. So in order to subtract, everybody see that in order for me to subtract, my denominator have to be exactly the same. And in this case, clearly they are not the same. And if they are not the same, our objective, how can we make it the same? And to make it the same, we want to factor them out and ask ourselves, what are we missing? And that's why when we went over chapter 6, I told you chapter 6 is very, very crucial or very important, because without know how to factor, it will be very difficult for you to do this entire problem. So looking at this thing here, by now, hopefully x squared minus 81, you probably like, I got it, Mr. Tran. This thing here is x plus 9, x minus 9, right? We have x plus 9, x minus 9, because this is the difference of the, and on on the second item here, do you agree that there are two numbers, multiply to give you 21, but subtract to give you no three number, sorry, be a 6, sorry. It should be a 6 to make it correct. Like I say, I make it up as I go. So in my head, I'm thinking of the 3, but it's still be a 6, guys, not a 3. Because we know that 9 times 3 is right? If the 3 there, the number have to be 54. But in my head, I'm thinking of the 3, so I wrote the 3. But it's supposed to be x squared minus 6x minus 27. And again, as we can see, negative 9 times 3 is negative 27. And negative 9 plus 3 will give me negative 6. So looking at this item here, this will give me, okay. So look at this item consistently or not, you know, very similar to before. This is my factor on this side. And now this is all you need to ask yourself is, in the blue circle, what do I don't have that there is in the red circle? Or basically, what are they missing from each repeated item? So if this is the repeated item, we don't need to insert them in, right? If this is the repeated item, we don't need to insert them in. So this is what they have in common. What are they missing? They're missing x plus 3. The red side, they're missing the x plus 9. So whatever they miss, insert in this item right here. So this is what we have is 8 x plus 9 x minus 9. What am I missing? Do you agree that in the red side there is an x plus 3 that I am, and in the side, am I missing from the blue side? Do you agree that this is what I have? Is I have a 2 x minus 9, and let me give me a x, which, and again, the only reason why I give the space is to show you that this is what I am missing. I'm missing the x minus 9. And if I put it in here, if I insert the denominator, I insert on the numerator. And once I insert it, x plus 3 is the exact sum of x plus 9, x minus 9, x plus 3. I'm plus 9, not x minus. Sorry, x plus 9 is what I, let me rewrite this thing here. This is x plus 9. The blue is x plus 9. And 9. Right? Again, I'm missing the x plus 9 on this side. In this side right here, I'm missing the x plus 9, not the x minus 9. So I insert in x plus 9 that I missed, right? So my denominator is x minus 9. And that's what our goal is we ask ourselves, what are we missing? And whatever we miss, we just insert them in. And once you insert them in, this is what we have is the denominator, the LCD. The denominator LCD is x plus 9. Regardless of your order, this is what you have. That's your denominator. And they are the same. And if they are the same, we kept one of them. And the numerator x plus 3 to x plus 9. That's why I'm missing, and that's why I insert them in. And again, after all this, I feel your pain. I here, we still have, we are not finished with this problem. And that's why I mentioned to you guys yesterday, right? Some of this problem will take the whole page. So, and depend on how, once we have this thing here, once we kept the denominator, now all we need to do is distributive the numerator, which is in the numerator, I have ax plus 4 minus 2x minus 18 all over x plus 9, x minus 9, x plus 3. And again, what do we do after this? Well, all you need to do is you can take the 8. What is 8 minus 2? That will be x, right? And 24 minus the 18. The 24 minus the 18, that will give me a positive 6, correct? And again, once we have that, this will be x plus 9 and x plus 3. And yeah, whoever say, oh, Mr. Tran, I got it, I can factor something out here. You could factor out a 6 to give you x plus 1 all over x plus 9, x minus 9, and x plus 3. And again, you still cannot cancel anything out. So that's good. That's why I use my iPad so that I can erase it. Just kidding. But yeah, it's a lot of loose leaf paper that you need to do. And again, you know, I know when we have regular traditional class, a lot of my students go through the because it's the end of the semester, they go through their notebook very fast with this kind of problem. But again, is a lot of tedious steps, and I hope that it's just tedious step that you guys miss. You know, it's not a complicated problem. It's just a lot of small tedious rule that you need to apply, and pretty much everything you learn, you know, every rule that you learned before is in this problem. And that's why if you miss one of the rule or you forgot one of the rule, it seems like it's impossible to do. But you know, all this thing here is just a small tedious step, one step at a time. So let me ask you guys, question here. Question, and in this step, in this procedure, or how to go or what to do in this problem. And one thing I want to point out for subtraction, just for subtraction, when you distributive this thing in, make sure you distributive in as a negative number. Make sure you distributive in as a -2, and that's the only thing different between the subtraction versus this. It doesn't change. It does not change the sign. Okay. Let's do one more. Let's say D. Same thing though. Let's say if they give you something like this. Let me give you something. X squared plus minus 2 all over x squared minus 7x minus 8. Right. So again, let's say if you have this problem, and let me give you some easy problem here. Let me ask you guys, well, see if you can work this problem here. See if you guys can factor them out, insert what is missing, distributive them, and then solve. See if you can do this one here. And the reason why I say the easy problem is because the factor of this thing is very easy. If you miss this factor, we are in a humongous problem, guys. So see if you can factor this. Let me ask you guys, the first step is see if you can factor the denominator. Factor the denominator here. Factor those for me. No one should miss this one over here. There's not be any excuse to miss a 3 because again, hopefully you guys see that there's only one combination of 3. 3 times 1 is 3, and 3 plus 1 is 4. Okay. And hopefully you don't make a mistake over here too, because there are 2 numbers multiplied to give you 8, but subtract to give you 7 is only 8 and 1, right? And one thing I want to point out, ladies and gentlemen, is most of the time when you factor them out, they will give you something as they have something in common, okay? And if you don't know the rule, one of them got to be positive, one of them got to be a negative. Well, we have the x plus 1. Most likely this over here will be x. And again, this thing will be minus 8 because of a negative 7, right? So the first item, as you can see, we haven't done anything new. The problem looked new, but this is all we're doing is we ask ourselves, what can I factor out? That's chapter 6. Now, the new thing is the LCD, which is what am I missing, right? What am I missing on this side, ladies and gentlemen? Let's say on my red side right here, what am I missing from the other blue side? What do I don't have? Well, we know this, what they have is they have the x plus 1 and x plus 1, right? They have those things in common. Everybody see that on the blue side, they have an x minus 8 that the red side does not have, right? So again, this is what we need to do is whatever we don't have. And again, let me do it this way. Let me insert x minus 8. And again, it's just you don't to just my habit is I put the big number first. It's just a small habit I have is I always put them in some these it's just one of those things that I keep on doing. You don't have to put them in order, but I just want you to see that this is what we insert them in, right? This is what we're missing on the blue side that the red side have. And again, and I just put them in order so that you guys can see that the denominator have x minus 8, x plus 3, x plus 1. So factor them out, ask of compare the 2 factor, what are you missing from one to the other? And whatever you miss from one from the other, you insert them in, you make it to be the same. And that's what the LCD is. You make the denominator to be the same. And once the denominator is the same, everybody see that this is all we need to do is we need to say 10x minus 8 minus 2 x plus 3 all over my denominator is x minus 8, x plus 3, x plus 1. That's our goal is we need to, instead of have 2 denominator, we combine them together and make one denominator have to have the common. They need to be the same. And that's what you do is you insert the missing item so that they can be the same. And if they're the same, you just combine the top And once you combine the top, everybody see that all we need to do now is distributive, get rid of this parenthesis. And again, coincidentally, is still a -2 up there. But again, if you distribute this item in on the numerator, we have 10x minus 2x minus 6 all over x minus 8, x plus 3 plus 1. And now very consistently the same. What is 10 take away 2? Well, 10 take away 2, that will give you 8, right? And a negative 80 and a -6, a -80 and a -6, that will give you the -86. And again, the denominator is just that, x plus. Yes, you can factor out a 2. You can factor out a 2, but you cannot cancel anything. So you don't really need to factor them out. But if you want to, right? If you want to, you can factor out a 2 up here. There's a 2 in terms that you have this item 43. And on the bottom, you still have -8, x plus 3, and x plus 1. And either this answer on top or the answer on the bottom is the same. But again, let me ask you guys again, question with this problem here, ladies and gentlemen. And again, yesterday, because I type it up and you know, I type it up and I told you that we need to find the LCD, but technically the LCD is basically ask yourself, what is your 2 item? What is the 2 item that you have, right? The 2 denominator that you, are they missing from one another? And whatever you miss from one another, you insert them in. And that's technically, that's what you do in the short, right? In the terminology, you know, in the math terminology, you have to find the LCD. You change the denominator, you change the numerator. But again, in short, you just insert what is missing. Whatever you've missed, you insert on the denominator. So you insert on the numerator. So again, I hopefully with the color coded, you see what I insert in from the red versus from the red versus from the blue. And again, and then you distribute them in and combine like tone. Question here, ladies and gentlemen. Is it clear? A little bit better second time around? Well, any question at all? All right. Well, this is all the time I have for today. Yes, it is not